Okay, we've made it to the integral of cos to the fifth power theta d theta. And this is actually not too difficult to evaluate. I can write the following. I could say this is the integral of cos to the fourth power theta times cos theta d theta. And then I could write this as cos squared theta being itself squared times cos theta d theta. And then we invoke our most famous of all trig identities, namely that the sine squared theta plus cos squared theta has to be 1. So that makes the stuff in the parentheses there 1 minus sine squared theta. So I get 1 minus sine squared theta. That expression is being itself squared times cos of theta d theta. And now I FOIL that out. Okay, so we get the integral of 1 times 1 is 1. 1 times minus sine squared theta is minus sine squared theta, and I've got 2 of those, so minus 2 sine squared theta, and then minus sine squared theta times minus sine squared theta is a plus sine to the fourth power theta, and this is times cos of theta d theta. And I'm just going to go ahead and write all of these the following way. I'm going to say this is the integral of 1 minus 2 times sine of theta squared plus sine of theta to the fourth power. Okay, that entire expression times cos of theta d theta. And now, at this point, what I'm going to recognize, and I've shown this in a previous video, so if you're not going to be too clear on what I'm doing here, please do visit my previous video when I did this, but I can go ahead and write the following. I can say d of, instead of theta, d of sine of theta is equal to, so the differential of sine of theta, we're using the chain rule here, is equal to cos, the derivative of sine is cos theta, times, now I have to do d of theta is d theta. Okay, so notice this. This, what I'm just encircling right over here, is equal to this, which is fantastic because everything in the parentheses is in terms of sine of theta. So I've just basically, now I'm going to integrate instead of theta with regard to sine of theta because everything's varying in terms of sine of theta. So this is the integral of 1 minus 2 of sine of theta being squared plus sine of theta to the fourth power d, you guessed it, sine of theta. And this is an exceedingly simple integral to do. This is equal to the integral of 1 d sine theta is sine theta minus 2 minus 2 times the integral of sine theta, that being squared of d sine theta. That's going to make it a cube over 3, so it's going to be minus 2/3 sine cubed theta plus, in this likewise fashion, this is going to be a fifth of sine to the fifth power theta plus some constant of integration. Okay, so all that to say that the integral of cos to the fifth power theta d theta is nothing other than this, what I'm boxing up. Okay, thank you for your attention. We will do the integral of sine to the fifth power theta d theta next in an analogous fashion.